Hi, I'm Carlos, software engineer here at Autonomys, and I'm mostly responsible for building the product layer over our DSN, our decentralized storage network. And today we are gonna talk about how to build with our solutions for permanent store. Today, I'm gonna explain the different products that we've built for using like the our Autonomys permanent storage. We internally call this the data access layer. That is basically, as I said, a suite of products that enables the developers to use Autonomys permanent storage. Depending on your use case, you'd want to use like more low-level solutions or higher level solutions. That low-level solutions would be harder to use, but with more could be able to customize much more the experience, and other solutions could be much constrained. Okay. For starters, I wanted to like explain a little how our decentralized storage network works, and like how we achieve to get this decentralized storage network. Our Autonomys is a blockchain layer 1 that relies on proof of archival storage. That is a consensus mechanism fairly similar to proof of capacity or proof of space. In terms that it requires farmers to pledge storage to the network in order to produce blocks. But there's a really important tweak in this consensus mechanism. That is that we make the storage pledge to the network useful. We achieve this by ensuring by making the farmers, instead of filling the pledge storage with random data, we make them, the protocol makes them store the actual blockchain data, the blockchain history data. So basically, with this setup, it's enabled our decentralized storage network, since now that farmers we ensure that farmers are storing our blockchain history data. A user, whenever, for example, uploads a file into our network, this file could start to be part of the blockchain history data, right? So eventually, farmers will start to submit proofs to the network, verifying that they are proving that they are storing that file in their pledge storage, right? And another a basic characteristic, a basic trait of blockchains is that they must be traceable, right? For this reason, blockchain history data is something that it's inherently permanent, because you have to be able to trace down all the history of the blockchain, right? For this reason, since our DSN is based on the blockchain history data, we can assure that our storage, our decentralized storage, is permanent. Okay, this was like a general more theory part of how we achieve to get this decentralized storage, and why is it permanent. But at the end, I just wanted to ground these ideas and these concepts, to make sure, to understand how this actually works, and how you could interact with our DSN. As I said, Autonomys is a L1 that, among other things, like AI agents or domains, that is like our execution layer, where we enable developers to create their decentralized applications. We have this permanent storage, and as in any other interaction with blockchain, all the interacting with the permanent storage is through transactions. Basically, there are some kind of special transactions that basically create that triggers the creation of an object in our DSN. So basically, if a user wants to submit data to our DSN or to create an object in our DSN, he should only create a transaction, pay the fee to the farmer, and submit the data to the blockchain. Some data and some facts about our DSN that are also worth to note is that we have some mechanisms to improve the data availability of the published objects, like erasure encoding, that basically makes that if some part of some piece of data is missed, then it's recoverable. And also we replicate we have all the objects replicated multiple times. For example, currently in our in Autonomys mainnet, we have a total pledged storage of 600 petabytes and a replication factor of 5 million. The replication factor is like the ratio between the total pledged storage and the current size of the chain. So that's like what is our DSN. And now I'm gonna going through all the different layers that we've got that enable the user to create products. The first layer that that could use some developer or some company for creating some solution of permanent storage is the subspace gateway. It's a really basic application that whose only functionality that is important but is real basic is just to retrieve one object directly from the DSN. So it connects to the blockchain nodes through an RPC, and it can extract a node from the network. An object. Objects in our DSN are content address, something similar like to IPFS. Basically, this means that the ID of the object depends on the hash of the same content that is referring to. So if I have an object that it's composed by a set of bytes, the ID is like the hash of that set of bytes. And in our case, it's a Blake tree hash because it's a really efficient hash function. And this is like the lowest level of abstraction and should only be used if your solution is not based on files and you want to create some sort of new format. And yeah, it's a weird case, but may have some use cases. Then we have the next solution that this is now much more feasible. Like this is something that it's not that weird. And it's the files gateway that basically it's a product that what achieves is the files gateway, basically what it does is extracting files directly from the DSN. One of the limitations that I didn't mention is that objects are limited to 256 kilobytes. This means that there's no one-to-one relationship between objects and files. So you need to basically create a format to encode files into objects. And then you need for reading from the DSN, you need some system that is able to translate those objects into the original file, right? So the files gateway is what it does. It reads from the DSN and it composes all the underlying objects into the original file. This solution is useful for many developers that don't want to have the burden of getting all the functionality that the next layer would have, like the higher level, like Autodrive that I'm gonna talk about in a while. But at the same time, their solution is based really in files. And as I said, as I said, we need like this formatting for to translate the files into objects in our JSON. This is made through our format that is autodoc data. It is based on IPLD that is quite similar to it's based on IPLD that it's the format in which is based also the IPFS format. So it's quite similar to the IPFS one. And yeah, basically that's what we created to solve this problem of encoding into the autonomy into the DSN objects. For if you want to build with the files gateway, you'll probably need to the files gateway. What it does is to compose the objects into the original file. But for doing the reverse step, like for encoding a file into the objects, we've created an NPM package that is Autonomys autodoc data that basically enables this use case. And yeah, with this and the files gateway, you can start manipulating files and like writing files and reading files directly from the DSN. Then we have Autodrive, that is like the easiest solution for most developers because it's almost a Web 2 experience because there's not quality involved. You have initial credits to test it out. In addition, you can claim more credits if needed. And it works through an API. There's also an SDK in NPM. But it's an API that basically allows you to upload files directly to upload files, and it implements some tricky things that like for example, there's a problem because when you upload a file into the DSN, there's some delay between you actually publish that and is on chain, and that's accessible through the DSN because basically they are the objects are created created in the DSN by batches. Like every 10,000 blocks are created. It's not constant and depends on the network bandwidth, but yeah, there's a delay. So handling this could be a little tricky, and Autodrive solves this problem itself. So for building like your first solution with permanent storage could be like the most suitable solution. Okay, and yeah, basically I'm explaining a little how to use it. Basically, we have a domain AI3.storage, in which you can set up a profile and create an API key. Then could be used with Autonomys Autodrive NPM package, and yeah, and with that you can use your API key and a really simple code to upload any file. And yep, that's kind of it. This is an example of how to upload a file. It's not even 6 lines, so that could be that's how easy it could get. And also an important thing is that for mainnet, we do have a public gateway for Autodrive that could be interesting for you, because when you upload a file to Autodrive, there's downloads are limited, so you are you have a maximum number in bytes for downloading. But we enable a public gateway for basically remove that constraint for this time at this time. So you could try that, and the URL is that. I could probably give it in a better format, but that's kind of it.